Welcome to the second in a series of NTPEP webinars that are aimed at introducing some of the newer evaluation programs. The first webinar was regarding spray-applied pipeliners and was held last week. That slide presentation will soon be available on the NTPEP website for those who weren't able to attend. I'm Bill Reel with NTPEP. For those of you who may not be familiar with it, NTPEP is the National Transportation Product Evaluation Program. NTPEP is an AASHTO technical service program that can provide savings to the states in the form of reduced manpower and other resources needed for in-house evaluations. NTPEP can also provide more complete evaluations in cases where states do not have a robust evaluation protocol in place. The way it works is manufacturers submit their products to NTPEP. The products are evaluated following an evaluation protocol that is designed by the appropriate NTPEP technical committee and balloted to the member states. The manufacturer pays a testing fee to NTPEP, and the testing lab works for NTPEP, assuring independent, unbiased evaluations. Results are made available to the member states online through NTPEP Datamine. States can then compare the NTPEP results with their own spec to determine acceptance of the products. Today's presentation will describe the NTPEP evaluations of concrete coatings and sealers, and this presentation is being recorded for future use. Questions can be submitted by typing them in the comments questions box on your screen. And so one of the hurdles of starting an evaluation program such as this is that manufacturers are reluctant to submit their products and pay the testing fees until they see the states are going to require them to do so. At the same time, states may be reluctant to require NTPEP testing until they see that a number of manufacturers have had their products evaluated by NTPEP. Given the potential benefit to states, it is important that states take the first step to get things started. So that said, I would like to encourage you all to watch this webinar, review the work plan which describes this evaluation, ask questions, and consider how this program can help you. Assuming that you see the benefits here, then it would be helpful to notify concrete coating and sealer manufacturers of your intent to require NTPEP evaluations of their products. Notifying them of your intent to use this evaluation will encourage manufacturer participation and provide the states with a robust, independent evaluation to base their concrete coating and sealer product acceptance on. So with that, I'd like to introduce Kelly Morse of Illinois, who is the Vice Chair of the Concrete Coatings and Sealers Technical Committee. Kelly?
Thank you, Bill. Hello, and thank you for joining us today. Today's webinar will serve as an informational overview of the NTPEP Concrete Coatings and Sealers Evaluation Program. My name is Kelly Morse, and I am the Chief Chemist for the Illinois Department of Transportation, and I am, as Bill said, the Vice Chair of the Concrete Coatings and Sealers Technical Committee. Carly McGee from KTA Tater will also be co-presenting and cover the testing lab responsibilities as they relate to the testing requirements of the work plan. I would like to take this time to introduce the other members of the Concrete Coatings Technical Committee. I believe they are all participating on the webinar and will assist with answering questions you may have regarding the program. I have attached a link to the Protective Coatings Technical Committee membership list. This list has our contact information and provides an opportunity to participate on the technical committee. We would encourage you all to become members and participate. Our chair is Todd Bennett from Missouri DOT. Again, I am Kelly Morse, Vice Chair. Our other Vice Chair for the structural steel side is Francisco from Louisiana. Our NTPEP liaison is Vince Blick from AASHTO. And the testing laboratory is KTA Tater, and Carly McGee will be presenting on their behalf. Again, this link is at the bottom of the page, and you may do that, hit that link when this presentation is online so that you may look at the technical documents in the committee at that point. NTPEP Concrete Coatings and Sealers began evaluating products in 2014. Ongoing concerns during the technical committee calls and discussions at the annual meetings prompted the technical committee to review the work plan in 2016. The primary reasons for the review included inquiries from states to add concrete sealers and anti-graffiti coatings to the program, as well as issues experienced by the testing lab with regard to concrete mix design and test specimens deteriorating during testing. The Concrete Coatings Technical Committee formed a task force to review the work plan and research the best practices in the field of concrete coating and sealer evaluation. Amongst those surveyed during this effort were SSPC, industry partners, and states. States were also asked about their needs in the area of concrete coatings and sealers. The test lab for the evaluations performed from 2014 to 2016 were contacted as well to discuss the issues with the work plan and any improvements that they would recommend. In addition, industry was approached to determine the relevant testing performed by those manufacturers to determine their coating and sealer performance. What the task force found was that AASHTO TP96 was successfully being used by other agencies to evaluate concrete coatings and sealers. The mixed design and testing protocols were being used to effectively evaluate the performance of concrete coatings and sealers. In addition, other agencies have in-house testing methods that include freeze-thaw and scaling resistance, as well as chloride ion penetration testing. The in-house methods were collected and reviewed and found to be similar in nature to AASHTO TP96 procedures. Anti-graffiti coatings were also found to be a need at the agency level. The issues with anti-graffiti coatings is the challenge of testing anti-graffiti coatings performance as it relates to the ability to repel graffiti and/or remove graffiti. The task force opted to focus efforts on the sealer and coating testing and hopes to add anti-graffiti coating performance testing in later iterations of this work plan. The task force chose to use AASHTO TP96 as the backbone of the new concrete coatings and sealer work plan. Due to its successful use by other agencies, it was considered a tried and tested methodology from which to build our work plan. TP96 includes the following testing parameters: sealer characterization, water vapor transmission, salt water absorption, chloride permeability, sealer penetration depth or coating thickness, UV weathering and cyclic saltwater ponding, and resistance to alkali. TP96 classifies sealers into two types: film forming or coatings that remain on the surface of the concrete, or penetrating or materials that penetrate into the concrete to some measurable depth. Concrete coatings and sealers are intended to provide the universal properties of reducing water and chloride ion penetration, extending the service life of the concrete, and it must be resistant to traffic wear and the various environmental conditions the concrete and coatings and sealers may be exposed. The general types of sealers and coatings as defined by TP96 include linseed oil, epoxy resins, silanes and siloxanes, methacrylates, sodium silicates, urethane, coal tar pitch, tar primer, and seal. The work plan includes coating systems that can be applied individually or as a system of multiple coatings. The key concepts the task force needed to address in the revision of the work plan were: 1, to find a freeze-thaw stable mix design; 2, fabricate standardized size prisms for testing procedures, and to combine those two elements to prepare sample specimens that would hold up to the rigors of the testing and allow the performance of the coating or sealer to be evaluated, not the quality of the concrete and/or the weakness of the fabricated specimen. Eliminating the weaknesses in the sample fabrication steps and standardizing the methods and mix design are vital steps to the program's success. The standardized prism sizes were gathered from ASTM and AASHTO procedures. For the slabs used in the program, they are 6 inches by 4 inches by 2 inches. The cubes are now 4-inch cubes, and the freeze-thaw prisms are now 16 inches by 3 inches by 4 inches. The task force was made aware of the industry concerns regarding the quantity of tests performed and the relevance of those tests to expected field performance. The task force attempted to streamline the testing to focus on the most relevant tests. The streamlining of the work plan should improve the timeline of results and lower the overall cost of the program for the manufacturers. The task force reviewed manufacturer technical data sheets for a variety of different materials that fall under the concrete coating and sealer categories. These technical data sheets were used to identify the test methods routinely used and reported on the sheets. The task force cross-referenced many of those typical methods found on the technical data sheets with TP96, and many of the same ASTM and AASHTO methods were employed. This further substantiated the move to AASHTO TP96 as the backbone of the new concrete coatings and sealer work plan. After extensive research and review, the task force identified the following goals and moved forward to rewrite the current concrete coating and sealer work plan by using AASHTO TP96 as its backbone, was work to standardize the concrete mix design or mix designs, standardize the test prism sizes, and work with industry, states, and testing labs to review and edit the final draft. The link shown on this slide will take you to the current concrete coatings and sealer work plan. During the following slides, I will provide excerpts from the current work plan and provide explanations of each. You will note that the visual quality of some of the slides, the work plan that were pulled from the online program, are not as clear and concise. It's not expected that you read them, but just to familiarize yourself with how the work plans are drafted and documented, so when you look at them later, they'll be clearer for you to understand. The following slides will walk us through the new 2018 Concrete Coatings and Sealer Work Plan. The program was formerly the Concrete Coating Systems Evaluation Program, and with the introduction of concrete sealers to the program is now named Concrete Coatings and Sealers. The new work plan is divided into 8 sections. I will now go through each section of the work plan to familiarize you with the program. The introduction and Section 1 scope provide a basic explanation of the program and include standard language consistently used for all NTPEP programs. Section 1 includes reference to Datamine and how to access results generated by the evaluation program. Section 2 is the reference documents. This section includes all the new AASHTO and ASTM methods used by the program and the primary standards used by industry to evaluate concrete coatings and sealers. Section 3 is the terminology. This just gives you some basic definitions of concrete coatings, sealers, and the coating systems, the different coats that make up systems tested by the program. Section 4 is the program overview. It covers the NTPEP guidelines, responsibilities, and expectations for the lead state, testing lab, and manufacturers who are participating in the program. This section contains standard language consistent with all NTPEP programs. Section 5 is the coating identification testing. This begins the technical aspects of the program, and this section outlines the testing that is to be performed by the manufacturer as well as the test facility. The testing is separated by generic category of product, concrete sealer and concrete coating.
Thank you, Kelly. I'd like to talk about the identification testing. It's also called fingerprint testing. It's performed to ensure that the qualified product is consistent with the product delivered for service. The FTIR is the infrared scans that is performed on individual components if the liquid coating material is a multi-component, as well as the mixed material, or if it's a single component material, the FTIR is run on that material only. Both sealers and concrete coatings are tested by FTIR. Concrete sealers are additionally tested for solids, specific gravity, and VOC. Concrete coatings are tested for VOC and solids using the same methods as the sealers. However, they're also tested for viscosity, density, dry time, flexibility, abrasion, water vapor permeability, pigment content, and tensile strength. Section 6 relates to
Sorry,
the performance.
I was muted. I've got it, Carly. Sorry. Section 6 is the performance test to be performed by the testing facility. It includes the heart of the program and where agencies will gain the most value from the program. This group of performance tests includes standardized procedures used to evaluate concrete coatings and sealers. Again, the two categories are broken into concrete sealer performance test and concrete coatings performance test.
For concrete sealers, testing is performed according to AASHTO TP96. 3 treated and 3 untreated cubes are stored at conditions of 23 degrees C and 50% relative humidity, and they're tested for moisture vapor transmission at 0, 7, and 14 days. The waterproofing ability is tested by measuring the weight gain following 7 days immersion in a 15% sodium chloride solution. The chloride penetration is tested by continuing the saltwater immersion and weighing the cubes at 14 and 21 days. The cubes are then split in half. Half is tested for chloride according to AASHTO T260 at 4 sampling depths, and half is tested for sealer penetration or thickness. Penetration depth involves immersing the sample in a solution of dye, and the coating thickness can be determined by ASTM D6132 or microscopic examination. Coating bond strength is evaluated according to the pull-off adhesion test, which is ASTM D4541. Skid resistance is evaluated for both treated and untreated specimens by the British pendulum method. Curing properties are evaluated differently for penetrating and coating type sealers. Both involve drilling a 3/4 inch by 3/4 inch hole in the cube. However, the coating type sealers are tested for gel time, tack-free time, and final set. Penetrating sealers are tested for initial and final drying time. In both cases, the testing is performed at 2 temperatures. Freeze-thaw resistance is performed according to ASTM C666 method A. Every 100 cycles, the sealed samples are weighed and visually examined. Samples are tested for a total of 300 cycles. The samples are evaluated on the concrete deterioration rating scale, and the freeze-thaw weight loss ratio is calculated. Moving on to coatings. For the coating type sealers, the moisture vapor transmission, waterproofing, chloride, coating thickness, dry time, and freeze-thaw are all tested by the same methods as the sealers. However, the only difference being that the tensile adhesion is tested following 50, 150, and 300 cycles. Adhesion is tested by the pull-off test. ASTM D7234 specifies the use of 2-inch pull stubs. For immersion testing, the samples are immersed in a 3% solution according to ASTM D6943 method A for a total of 28 days. The samples are examined for blistering every 7 days. Color and gloss change are evaluated following 28 days. UV resistance is performed using ASTM D4587 cycle 2, which is 4 hours of UVA light from UVA 340 bulbs at 60 degrees C, followed by 4 hours of condensing humidity at 50 degrees C. The total exposure time is 2,500 hours. Samples are examined for blisters, and they are photographed every 500 hours. Color and gloss change are measured following the exposure.
Thank you, Carly. Section 7 is the test specimen requirements. This section is a key update to the work plan. This section improves upon the mix design guidelines and provides a concrete mix that can withstand the testing extremes. It also now utilizes standardized specimen sizes known to perform well under the test conditions. This chart is a summary of the mix design guidelines as found in TP96. During the task force research, survey respondents indicated that agencies using these guidelines to prepare the concrete mixing for testing were able to produce a mix that was successful in holding up to the testing conditions. These guidelines were reviewed by other agencies with freeze-thaw tolerant mixes and found to be similar. The task force decided to move forward with these guidelines as the mix design guidelines for the work plan.
Thank you, Kelly. The test specimen requirements are discussed in this section. We're using wood molds to fabricate the specimens. No form oils are used. The maximum nominal aggregate size that we're using is 3/4 of an inch. We're using a chloride-free lignosulfonate water-reducing admixture. The concrete mix is air entrained, and the fabrication is performed in accordance with ASTM C192. During the batching, we're measuring slump, air, temperature, and density, and all specimens from a submission are fabricated from the same batch of concrete. We cast 3 compression cylinders with each batch. Specimens are covered and demolded after 24 hours of wet cure. The moist cure is in accordance with ASTM C511. The curing range is from 28-day minimum to 182-day maximum. When the specimens are ready for test, they are weighed and labeled, and then representative samples are selected for total moisture and baseline chloride determinations.
Section 8 is the testing protocol. This section provides the application procedure, the test to be performed, and the type of specimen, number of tests, and the duration of the test. The work plan, as you've noticed throughout the slides, utilizes tables instead of wording and description to summarize the work plan details. This was done in an effort to make the work plan clear and concise so that the testing lab and any of the end users, when they were working to specify, could look to see how the program evaluated things in a tabular format, so then they could take that and develop their specification requirements at the agency level.
There are 3 specimen types: moisture vapor transmission, waterproofing, chloride, coating thickness, and dry time are performed on the 4-inch by 4-inch cubes. Adhesion, immersion, skid resistance, and UV resistance are performed on the 4-inch by 6-inch by 2-inch slabs. And freeze-thaw testing is conducted on the 16-inch by 3-inch by 4-inch prisms. In all cases, there are 3 replicate specimens prepared for each test. Once the specimens are fabricated, the surfaces are lightly blasted to remove loose or friable material. The samples are then blown off with clean compressed air, and the moisture content is adjusted to 50% for slabs and prisms and 70% for cubes. All of the coatings are applied according to the manufacturer's instructions. Coatings are applied to all surfaces of the specimens. Sealers are applied by either immersion or brush application. Coatings are applied by airless spray, and complete records of the coating application are kept. Parameters that are recorded include tip sizes, pressures, hose lengths, ambient conditions. All of those things are recorded on the application forms. And successive coating layers are applied at the minimum recoat time, and that recoat time is specified by the coating manufacturer. Dry film thickness is then measured per ASTM D6132 for coatings. D6132 is the ultrasonic gauge method. And then the coated samples are cured for 30 to 45 days at controlled laboratory conditions unless otherwise required for a specific test. Some of the tests are conducted starting at either 7 or 14 days, but for the most part, they're all started at between 30 and 45 days. All of the specimens are photographed prior to the start of testing. An entire submission requires 29 weeks for the sealers and 32 weeks for coatings.
Testing data results are maintained in an online database, NTPEP Datamine, at data.ntpep.org. Access to data in Datamine does require a login. Vendor data is kept confidential between vendors, and DOTs have access to all of this data. To submit an application on the industry side, all an industry participant has to do is log in the Datamine, click Submit an Application underneath the Concrete Coatings Technical Committee section, and begin the application process.
The request for a standardized one-stop shop for evaluating concrete coatings and sealers has been created. This new work plan includes current best practices, AASHTO TP 96, and has been used successfully by agencies since 2013. Industry has been a part of this review and revision, and the concerns with the old work plan have been addressed. Now it is time to start implementing the new concrete coatings and sealers program. The benefits to the manufacturers is that now they have one place to send material for evaluation, and those results can be shared via Datamine to all the agencies to use to compare to their own specifications to verify compliance. The benefits to agencies are the ability to have a clearinghouse of testing data gathered using standardized test methods on materials widely used in construction and maintenance. The next steps are for the agencies to start requiring the concrete coating and sealer program and to recommend to any concrete coating and sealer manufacturer to use the program as well. I think we'll now open it up to questions. If anybody has any about the presentation, either for myself or Carly or the other technical committee members that are on the webinar. I haven't seen any type up in the chat box. Does anybody have any questions? Can you open it up, Vince, for audio for everybody?
For any questions, feel free to type them in the question box in the right-hand side, and they'll populate accordingly. We have received an informational note from a Mr. David Kaniga at PennDOT. AASHTO TP96 has been withdrawn to be replaced by AASHTO T384 as a full standard. The new standard is identical to the original provision standard. It's just been adopted into a full standard designation. Thank you, Mr. David Kaniga. Are there any other questions I would like to populate in the question box for review and regard? We have a thank you from Tennessee, Mr. Richard Weber. Thank you, Richard.
Okay. Well, if we have no questions, I'm going to go ahead and move forward. If you would please join us for our upcoming NTPEP webinars. Next in the series is detectable warning systems, and following that will be the epoxy and resin-based adhesive bonding systems. We thank you for your time today and appreciate your interest in our program and hope that we can move forward with implementation and get this program more populated. Thank you for your time.
We can circle back real quick with a couple questions that have populated. What are the resubmittal dates? We have opened the submission window. It is currently open and you can submit at any time. The next question from Vicki Stewart. Will we be able to see everything in print? All of this presentation material will be distributed post-webinar, and it will also be posted on ntpep.org. Additionally, a link to the video that you're currently observing will be included post-webinar. An additional question. Expiration, length of time before renewal is required. I'll steer that question to Kelly Morse.
All right, I am looking. I don't recall the resubmission window. I'm looking. We will have to follow up with that. I'll add that to the information posted with the webinar. Todd, do you know?
Sounds good.
I don't see it actually. We'll follow up later with that information.
Sounds good. We have a question from Paul Vinnick. Where is the information regarding the upcoming webinars posted? We'll have that information posted along with the post-webinar email regarding additional upcoming webinars. We will also include it on NTPEP.org as a reference in the news and announcements. Okay. Looks like we have concluded the question population. And all right. With that, if there is any other informational items from Kelly or Carly, I'll go ahead and move to conclude this session and appreciate everybody's coming out to join this webinar.
Thank you very much.
Thank you, everyone.